And we are live.
Okay, just give me a second and we will start. Hello, hello. Just one more second. Okay. So, let's start. I'll just close the door 1 second. So, today our fourth Q&A session, and I think it's a good idea when we start our Q&A with some explanation of one general topic, and then we go answering your questions. And today Q&A, I wanted to talk about the motors and motor temperature. I made already once the topic about the motor winding and how to choose one. I will quickly sum up this topic. So the motors for Typhoon and Vortex, they can be in a, I think I don't need the headphones, so I can put it like this with the mic directed on me. I hope it's going to be okay. So there are different types of motor windings. For Typhoon specifically, we have a 3T, 4T, 5T, and 6T. For Vortex, we have only one motor winding, which is 3T. And there is a reason for this. To start with, what is a motor winding? Inside the motor, you have a poles, and each pole has different numbers of winding of the copper wire. That's where you have the 3T for 3 turn, 4, 5, and 6. And the more turns you have, the less cross section of this wire will be, but then with the less current, you will have more torque. So if you think about this, you always would say, okay, then why not to go always with biggest torque? Because with bigger torque, you lose maximum speed. And it's almost like gearbox in your car. So with a 6T motor, your top speed with 72 volts battery will be, let's say, about 55. But with the 3T motor, it will be around 100 kilometers. So you can see here the trade-off between top speed and torque. Why we go only with a 3T for Vortex? Because the Vortex has a gearbox in terms of the rear sprocket, where you can change the size of the sprocket and change the ratio between the motor speed and the rear wheel speed. If you want to hear more about how to choose a correct motor for you, please watch that video. I will include in the comments after the video the link for that video which I did over a year ago. So what I wanted to talk about, which I didn't talk previously, is the motor temperature. And at this moment, there is only one way where you can check the motor temperature. And this way is by connecting through the Bluetooth or computer to the controller. And then in the page of monitoring, you have different parameters. And one of the parameters is motor temperature. So I did it. You can put your phone on a phone holder on the handlebars, and at any point of time you can check your temperature of your motor. Also, you set the limitation in the controller for your maximum temperature of the motor. And at the point when this temperature will rise and reach almost the limit, the controller will start limiting the power. And if the temperature will still rise in anyway, when it will reach this critical point, the controller will cut the power completely. So you push the throttle and there is no response. When this is happening, you can think about this again, just to make it easier for you, probably as the same situation with the car. Imagine you stay with your car on a hill and you need to go up, but instead of accelerating on the first gear and then switching it to the second gear and to the third, to the fourth, you turn on the first gear and then give throttle enough only to stay at one place. Do you do any work? Useful work? No, because the car don't move anywhere. Do you spend energy? Do you burn the fuel? Yes. Will your motor overheat eventually? Yes, because there is no airflow and your motor working hard to keep your car on the hill and not rolling down. So the same with the bikes. If you stay on a steep hill and you use very little power just to stay or barely moving ahead, of course, with a bike it's not possible because you have just two wheels, so you cannot stay at one place, right? You need to move. But if you're gonna move with a very, very slow speed, let's say 5-10 kilometers per hour, and if you will look at the motor rotation speed, for this speed, if you don't have very little wheel radius or diameter, then I will bend my camera a little bit. So if you don't have a very little radius or diameter of your wheel, it means that the speed of rotation of your wheel will be almost zero. And in this mode, you spend a lot of energy from your battery and controller. For controller capable. Okay, I sorry for interruption. I was looking at the questions that you're writing live. And you spending energy, you produce heat inside the controller, you push the current through the motor, but you produce current enough only to barely push the bike uphill. So there is very little useful work, but you spend a lot of energy to keep your bike on the hill or barely moving it up. What are the solutions? Of course, first of all, don't ride uphill, right? But if this is your intention and you want to go uphill or you want to climb a mountain or something, then it's not an option. What you can do else? You can go ride in more efficient way. What is more efficient way? This is when your wheel rotation or motor rotation will be in the optimal condition, or at least in the boundaries of the optimal conditions. And this is definitely not the first couple kilometers per hour or miles per hour, no matter which motor you have. Because the motor has a different resistance, so to say. And it's not only resistance inside the copper wire. And all those resistance, they sum up, and you spend a lot of energy and produce heat without making any useful work. So my recommendation is always, if you ride uphill, and especially steep uphill, always stay 50% or higher from your maximum speed for this exact motor. What does it mean? Imagine you're riding up the hill, or you're driving on the mountains, and you're riding, let's say, 5T motor. What is the maximum RPMs for this motor? This is approximately 650 RPMs on 72 volts. In terms of kilometers per hour, with the 18-inch motorcycle rim and 3-inch tire, that will be about 70 kilometers per hour top speed with a charged battery. So what's going to be the 50% of this speed? 35 kilometers per hour. And what does it mean? That if you're gonna ride uphill with your 5T motor with an average speed of 35 kilometers per hour or higher, you will be in the optimal boundaries for your motor. Of course, it can be in 30 and 25, but the slower you go, the more energy you waste into the heat inside the motor and not for useful work. And here we have a big difference, especially for the e-bike that has motor inside the wheel, where you don't have an option for the gearing. And here you can only change your optimal speed boundaries by changing the winding inside the motor. So again, there are 3T, 40, 5T, and 6T. And let's say if you compare this 50% from the top speed of 3T motor and 6T motor, the 6T motor will be more or less efficient already from 20-25 kilometers per hour, when the 3T motor will be efficient only from 45-50 kilometers per hour, which is already high speed. And you need to think, if you are riding in the mountains, you may not even have a possibility to reach this speed to be in efficient mode. So your option will be, of course, to ride with a slower speed, and this slower speed for this particular motor will not be in these efficient boundaries. So you'll waste a lot of energy into the heat. Also, why riding slowly will cause overheating eventually? Because for your e-bike, you don't have an external radiator like inside your car, for example, and liquid coolant. So if you ride in slow, the airflow from the outside air is very inefficient and very slow. So the heat exchange between the motor side covers and the outside air is very slow, and it won't be enough to dissipate heat that created inside the motor. While if you're riding on a higher speed, you have faster velocity and speed of the air that flow around the motor, and you can dissipate more energy in term of heat from the motor by just driving faster, and that's way more efficient. So why do we have only 3T motor for the Vortex? Because from what I said previously, you may think, well, then it means that Vortex is not efficient at all for the climbing mountains. But here it is opposite, because 3T motor has big cross section of the wire in windings, and it spins very fast comparing to other winding types. But what's the minus of this motor? That the efficient boundaries are relatively on a high speed. But if we use the gearing system for the 3T motor, like we do on the Vortex model, we can decrease the top speed of this bike with this particular motor. And in our case, it's 2-to-1 if we use the biggest sprocket on the back. And even riding with a speed of 20 kilometers per hour, it will be more or less equal as if you would drive the motor 3T on a Typhoon with a speed of 40 or 45 kilometers per hour. And you see here what the difference is. You can ride the high-speed motor on a slow speed and still being efficient. So that's why the Vortex model probably better choice if you want to ride very, very steep hills on a slow speed, because here you can use the gearing system, while on a Typhoon the only gearing option you have is changing the whole wheel together with the motor. Of course, it doesn't mean that you cannot climb the mountains on the Typhoon as well, and you can watch plenty of videos on this channel as a proof of my words. But the temperature of the motor will eventually reach the critical point where controller will cut the power. And the heavier the bike and the rider together, the faster it's going to happen, because you need more torque to push higher weight uphill, right? So what are the solutions? I said already not to go up. I said the solution number 2 to go in the optimal range. Solution number 3 to ride it when it's bigger delta temperature difference between the motor and outside air. It might not be too much, but if you compare it, for example, here in Germany, riding in the winter or spring and autumn when the outside temperature is minus or 0 or plus 10, and then you compare it to riding in a hot summer day when the outside temperature is plus 35 and it's sun, or if we talk about some countries where it's plus 40 or higher in the summer, then your starting point, your starting temperature of the motor and all internals component of the bike will be already the same as the outside temperature, right? So you will start already with plus 40 degree, and you probably will be in a situation when it's not the motor which will suffer first, but probably controller or the battery, because the smallest operating temperature inside the whole bike is not the motor. The motor can reach, especially the windings, 140 degree before the controller will cut the power. But the controller itself will cut the power as soon as it reaches 90 degree. And the battery BMS, battery management board, will cut the power as soon as the battery cells, I believe, reach 60 degree, just to protect it. So you can see here, when you start riding with a 40 degree already, you only have this delta of 20 degree for the battery before the BMS will cut the power. And that's why I said before, and probably it will be topic for the next Q&A session, that if you ride in the places where it's really hot in the summer, you really need to have a battery with low internal resistance, so it will not generate a lot of heat. Because for the regions like I live, it's not that important, because if it's outside plus 20 or plus 10 or 15, you have enough delta big enough for the battery to not reach the critical point. Yeah, but today we talk about the motor. And the rule here is more or less the same. If you're riding on a hot summer day and the sun is very strong, even if you just leave the bike outside on direct sunlight, your motor will reach high temperature, maybe 50, 60, 70 degree, even without pushing any amp through the windings of the motor. So my recommendation here will be, if you're riding on a hot summer day, you can turn off the regen from your brakes, because when you're regenerating, the motor acts like a generator and still generates some heat inside the winding. So at those moments when you're not pushing the current through the motor, and which theoretically motor can use to cool down or lose some energy as a heat dissipation, you still generate heat because you're using regenerative braking, right? So my recommendation will be to turn off regeneration at those points. And next recommendation will be, when you stop, just keep your bike in the shadow. If there is no place to hide your bike, let's say you're riding in some field and there is no trees next to you or something like this, don't leave your bike perpendicular to the sun, right? So put it along the sunlight. So you have a smaller square area of the bike that affected by the sunlight. You can also put the, for the complete bike, the side covers with the ventilation and so on, but it will not affect the motor. There are some solutions like making ventilation on the side covers of the motor. You can put the ferrofluid inside the motor. You can put the heat sink on the motor to dissipate more heat. But here comes but. We did the testing. We took a Typhoon bike and we did 30 accelerations from complete stop to top speed, and we recorded the temperature change after each 5 acceleration. So you stand still, you accelerate to top speed on the maximum power, the phone connected to the controller, and you record down the temperature of the controller. Then you do 5 more, 5 more, 5 more, and like this you do 30 accelerations. I did similar test on this channel where we compared how fast the temperature rise with regeneration and without. This is another video, you can find it on our channel. It's very interesting, as for me. So we did 30 acceleration for the hub sync test. And for those who don't know, the hub sync, it's like the extra metal fins which you can put on your motor for bigger dissipation area of the heat. Yeah, so we did like 30 accelerations, and after this we installed the heat sink on the motor. The same bike, everything's the same. We even did it on the next day, so to let the bike and the motor completely cool down, right? So it won't be unfair comparison. We basically replicate the conditions that we had on the first day, and we did it on the second day with all identical situation. The rider was the same. It was not me, but the rider was the same. And we did the same test with 30 accelerations with the hub sync. And we almost didn't see a difference. And here can be couple ideas why. Well, first of all, we didn't use a ferrofluid, but I'm not big fan of ferrofluid because to add ferrofluid, you have two options. First option, you need to open the side cover of the motor and break the seal. And second option, you need to drill a hole to add ferrofluid and then to close this hole somehow. And we have a couple of clients who did that and who lives next to the sea where the sea water and salt in the air make the corrosion much faster for the steel, for the copper, and so on and so on. And I would definitely not recommend to open the motor to break the seal. At least if you do this, you need to put the sealant on a whole parameter of the motor and put the side cover only then. So that will be my recommendation. Maybe if you add ferrofluid, the result will be different, but then you face with another problem. What other solution? To make the holes on the motor, but here you have also two options. You make just the holes, then you need them to have those a lot of holes in the area next to the winding. Or option two, you can make the holes and then install the fans inside the motor so they will push the air even when you don't move or something like this. This will help, but then again, you have holes on the motor, and if you're gonna ride through the sand, dirt, rocks, it will get inside. Even if the water get inside, yes, it will evaporate, it will go out fast because the motor is hot, it's not the problem. But if you're not riding only on a clean surface and you're riding through the sand, dirt and so on, it will get inside and it will work as a sandpaper. So it will damage your isolation, it can damage your Hall sensors, it can damage the motor in general. So here you have a very short life of your motor, and if you're not ready to change magnets and stator of your motor very often, then it's also not a good idea. It's like, buying some small resistor and then trying to compensate small resistor power by big radiator. There are some limits. If you need more power, you just need to take the bigger resistor. You cannot always compensate the heat dissipation with bigger and bigger radiator. The same is here. You need to understand the efficient way of riding the bike. And believe me, if you will remember all those tricks that I said before in this video, like cutting off regeneration when you don't need it, riding with efficient speed, trying to build momentum riding down before you get up, to not accelerate from the stop only on riding uphill, but having some momentum driving to the hill, and so on, or just keep your speed constant on the way up and not accelerating. Believe me, you, even if you will have overheating, it will start much further later. It will start much later comparing if you don't do any of those. And in some situations, it can be the difference between having overheating at all or not having them completely. Just for example, one of my last trip to the Alps, I took the Typhoon Light, and I wanted to check the capacity of the battery and do some test, not about the motor, but I was riding with all above mentioned tricks uphill, and the first thing that suffered from overheating was not the motor, it was the controller, because the controller was inside in the closed frame area and so on. I didn't check the motor temperature by the phone, but I touched the surface and it was hot. So of course the motor was not cool or like ambient temperature, but the motor was not the first link to suffer from overheating, right? I'm sure if I would not, use all those tricks, I would have stopped much earlier because the motor would reach this critical temperature. And yeah, just if you're watching this, you're probably interested in things like this. And next time when you go ride, just keep in mind those small tricks, and you will see how much further you can drive uphill. Because most likely you have overheating if you're driving uphill. You don't need that often push the motor that hard if you ride on a flat surface. Another thing that you need to think about what increase your energy consumption is like low pressure in tires, heavy weight, fast face wind direction, right? So imagine you're riding 20 or 30 kilometers per hour and wind blowing 20 kilometers per hour against you. So this will be equal to wind resistance of 50 kilometers per hour riding, right? So sometimes you cannot avoid it, of course, but this is just a part of the equation, which when you sum up all those small parts, you will get the result. So yeah, this is something I wanted to talk about today, about this overheating and ways to avoid it, and other methods that exist on the market. Again, as I said, I think the most important here is just to choose the right motor for you. If you're riding on a flat surface or you're riding in the mountains, what top speed you need, and keep also small tricks that I said available for you, and then you will see you'll get much better results with overheating, or you won't have them at all. Guys, you can ask me questions here live. I will answer them as well. I will start with the questions that we received under the previous Q&A a week ago. Here was exactly that's the reason why I started to talk about the motors today, because some of the questions that we received under the video of previous Q&A was about the motor. So the question or the comment was, I need something to monitor the heat in the motor on the display or a separate meter so I can know when to slow down. It happened a few times. I got stuck on a steep track. Not good. Usually just switching off the motor and switching on again will get it to work again. Then it is a matter of going very slow until you find a place to stop or let the engine cool down a bit. Also, the tip to prevent overheating when going downhill, regen braking, the question about ferrofluid, I will come back to this. Also, the tip to prevent overheating when going downhill, regen braking also can cause overheating or less down cooling down of the motor when you go downhill. Switch off the motor just um, just use the mechanical brakes. Regen braking does not generate a lot of extra travel time anyway. And here the comment basically talk about the same what I just said previously during this video, and also the guy, the name is Red Capsule, said that he would like to have a device that he can use to monitor the motor temperature. And I already explained today how it's possible. You can just connect your phone to the your controller, and you will be able to see live the temperature of your motor if it's important for you. And he talked about the regen, what I said before as well. About the regen, one more point. I agree, kind of like when you go up and down, up and down, that regen is not helping you to cool down the motor, but for me, I often go to some like big mountains, and for me, it's not going up and down, up and down. It's more like, go halfway up and then after a break going down. So if I make a break on top of the mountain or something like, on the middle of my trip, the motor has enough time to cool down, not completely, but lose maybe 20-30 degree from where it was when I just stopped. And then there is no point for me to not use regen on the way down. First, you save your brake pads, you not overheat the components of the brakes, and then you have a longer life of your brake pads. And secondly, even if not much, but you still charge your battery on the way down. And from the last trip again, when I was with Vector Typhoon light on the top of the mountain, I got something like 9.4 amp hour available in the battery. And when I reached the parking place next to the mountain, after descent, the capacity was maybe 10.7 or 10.8 amp hour. It was not always regening, it was also mechanical braking, and sometimes I use a throttle to accelerate, so it was not the energy recuperated from the whole hill on the way down. But still, yeah, you see, we end up next to parking lot on the bottom of the hill already, with extra energy inside the battery, which is nice, but of course it's nothing comparing to what we saved in terms of the brake pads. Next question was could you make a video on the shipping to different countries? I'm in the US, so I'd like to know about the time and payment and shipping. Thank you. It's a good question, and I think it deserves a similar Q&A episode where I will explain at the beginning some topic in details, and then I will answer the question. So I think we will do the next one about the shipping. Can you please do a review of the latest version of the Typhoon? I'm very interested. So the latest version of the Typhoon is not exactly the same as we had on a review on our website, but it didn't change much. We have some minor changes on the frame and on some components, but they are not that critical. But Yeah, thank you for the suggestions. Uh, After my trip next week, I will try to find a time and record a video with Typhoon, maybe even with the Vortex, with the latest models to show and update it on our website. Good suggestion. Um, what other questions we had? Let me see. Boss Monati, hello. Nice to see you. So let's start with the first questions. I'm using liquid metal. Is it a good choice? You probably talk about ferrofluid, and I think I already explained in this video about ferrofluid that it's good, but it has its own negative sides. And to add it to the motor, you need to break the seal. So make sure you will also restore the seal. Otherwise, the humidity in the air, especially if you live in the places next to the sea or something like this, or rainy places, it will get inside the motor and you will have a lot of rust if you don't cover your steel and magnets additionally. Mm. Hello, you tested how much the step down converter reduce the battery capacity when the light is not on? Yes, if you basically turn on the key on the bike, the step down converter has it use some energy, but not that much. With even with the smallest battery on a Typhoon Light, you can leave the bike turned on for a week, and I think you will not discharge the battery completely, even even leaving the bike turned on for the whole week. And here I'm talking only about the bike. Of course, if you will leave your headlamp turned on, it will discharge your bike. Maybe not in one day, but for sure. Um, Suggestion for controller capable of 2436S, 100 to 136 volts, 200 amps. Oh, there are plenty of controllers, even from like different brands that can work in this voltage. You can check, there are many Kelly controllers. We use a Kelly controller. We work with the Kelly brand for a long time already, and they have a controller that can work with the voltage higher than we use. We use 72 volts battery for a couple of reasons. I think I explained it because, first of all, it's already not as safe to use a battery with 136 volt comparing to 72 volts. It's 2 times higher voltage, so it can be dangerous. And secondly, the top speed is pretty much already good enough to not suffer from this. uh, I use 150 amps and battery is 124 volts. Yeah, you see, like plenty of controllers. Just make sure the controller you're looking at will be a sine wave controller, because if you use a square wave or trapezoidal wave controller, they will create this extra noise in the motor windings, and I think it kills the whole spirit of the e-bike when your motor creates this noise. It's like it's much cheaper controller because they use much simpler logic board. But you know, I guess everyone who tried once the sine wave controller don't want to switch back to the square wave. I might be wrong. Maybe somebody likes the sound, but definitely not me. Hmm. Hi Arthur, will be ordering frame and motor by email very soon. Thank you. Thank you for support. We try to do our best. I hope our prices are lower on the market. If you can try something that we offer somewhere with a lower price, please send me the link if it's real price of the real product, we will try to lower our price as well. But so far, I think we keep our prices as low as anybody else, lower than anybody else, I wanted to say. Sorry, what did you say before about the ferrofluid and fast corrosion? The ferrofluid make fast corrosion. You mixed up. I think I already explained it. Not ferrofluid, but the way how you add it. You need to open a side cover, or you need to drill a hole in the cover to add ferrofluid. Right? It cannot get inside through the wire or something like this. And that's where you need to be careful with ferrofluid. What else we wanted to talk about? Just give me a second. I will look at the other questions that I saved for later. About the motor, one more thing that I wanted to say. I had the idea first to add on the bike some temperature meter, which will be connected to the motor temperature resistor. But the problem is here the temperature sensor inside the motor is specific type. It's KTI83, and it's very hard to find the temperature meter which use the logic developed for exactly this temperature sensor. Most of them work with a different temperature sensor type. Also, right now, the motors that we use have two sets of Hall sensors. The second set is completely spare, so if something happened with your first one, you don't need to push your bike all the way home. If you're far away, you can just switch the holes, and it might not work in the optimal condition, but at least it will push you push the bike further, and you can back home. But there is only one temperature sensor inside the motor, so first or second Hall sensor, they both connected with the pins that correspond for the temperature to one temperature sensor. And this doesn't allow us to use any additional device if your controller connected to temperature sensor of the motor. And there is no way I would recommend to somebody connect a temperature meter, thermometer for the temperature sensor instead of the controller, because the controller is something can stop you if you don't pay attention, and not the temperature meter. Let's see other questions we had. Just give me a second. Is it a good idea to buy a bigger motor if you need to push a higher current and ride on a higher wattage? Yes, if you see that 10 kilowatt peak is not enough, or you ride very aggressively all the time, hard acceleration, hard braking, you can go with a bigger motor. For Vortex, it's probably not the case, because I don't know what you need to do to overheat this motor on a Vortex, because it has additional cooling ribs on side covers, and because of the gearing system, it's very hard. But if you think about the Typhoon and you need higher current, higher power, you can go for 273. Hello, 273 motor. The reason why I don't like this motor and we don't offer it, because of the extra weight. It's 50% heavier than our motor, and I think our motor is heavy enough. I'm not happy. Believe me, I'm not happy with the weight of this motor. But it's like there is no free free cheese. It's always some compromises. Of course, there are ways how to make this motor lighter, and it's not a secret for me or from factory. I talk with them many times about this. Okay, let's guys, I will order 100 200 motors if you do it like with the changes that we recommend, like this and this, and it's not a secret anymore. I think Green Technology is a company in Canada. They did a very good light motor, but it's not as powerful still as the motors we use. If they would have the motor with the same power rating as we use, I would definitely try this one. But so far, the motor that we have is the best what's available in terms of weight and power that you can push through this motor. Of course, you can go with a bigger motor and push it even more, but it's always a compromise. If you want or ready to ride with a motor that weight almost 20 kilograms, go for it. For me, 13 kilogram is already a lot. 12, 13 kilogram, it's pretty big weight. If you increase your weight, your rear suspension won't work at all. Plus, you're risking of damaging the rim because it's unsprung weight, and yeah. In some places, it makes sense. If you're riding on a smooth asphalt and you need to ride fast and push high power, yeah, maybe a good solution. If you want to ride on a mixed terrain, asphalt and off-road, or off-road only, then I don't like this idea at all. Guys, ask me a couple of questions more because we're reaching 52-minute mark now, and yeah, I want to keep this session under 1 hour. So if we won't have more questions from the live viewers, we will probably finish it soon. Okay, I will answer other question. What you can do to prolong your motor life? Well, there is such called what happened to your hair? I was riding too fast and it's all blow off. So there is a so-called I forget the name of the point in the temperature of the motor for the magnets, which you cannot exceed. If you take any magnet and you heat it above certain temperature, first they start losing their magnetic power, and at some point they can be demagneted at all. So it will be just a piece of metal without magnetic field inside. So this is you need to take care about, and how you can pay attention to this, not overheat the motor. So as I read before, if you ride in and the bike stop, yes, you can turn off the key, turn it on immediately, and the bike will continue riding, because by doing this you kind of fooling the controller for a short period of time. But doing this will lead to overheating, and if not melting the isolation of the winding, then at least hello, then at least you can overheat your magnets on the motor. And if you overheat your magnets on the motor, then it doesn't matter how many kilowatt you push into your motor, it will not generate any torque, because for generating torque there should be two components. First is a wire that create that let electricity to go through, and another component is a magnet next to this wire. So if your magnet will stop being a magnet, then your motor will not generate any torque. And so I would not recommend to, use the skin with turn off key and turn on and push and hard and hard and hard, because we had some clients who used their bikes for many years, like 3-4 years, and then they come to us and said, look, the motor doesn't pull as hard as it did at the beginning. What's happened? And we tested the magnets. They were much, much weaker than before. And we asked, did the client change the settings? And yes, they increased the temperature limit on the controller, which lead to losing magnetic force of the magnet. And eventually your motor became just one big resistor, without generating much torque. So this is something you need to pay attention. So do not overheat it above critical temperature. Next thing that you can do is to protect it from the humidity and salt water. If you live next to the ocean or sea, that's very important. And that's again why I say the ferrofluid, if you open it and you break the seal, it will lead for extra humidity inside your motor and you will have more rust. The rust build up not overnight, but the more rust you have, it starts grinding between the magnets and wires, and it became a dust. So it's something you don't want to have inside your motor. We have a clients who ride their bikes for 3-5 years, and then we open, they look like new. And we have a clients who ride half year and then the motor stopped working at all, the bearings stopped working smoothly, and inside there are plenty of rust. But yes, if you open your motor or if you wash your motor um, with a car wash, don't put the water inside. The places where the water can get inside is the cable, the places between the cable and the side covers, or if you break the seal, it's like between the side cover and the rotor of the magnet. So please be careful about this. And if you open the motor, you can of course cover it with a varnish. The varnish should be heat resistant varnish. It cannot be any varnish you had in your basement. So buy please a varnish that can resist at least 200 degrees Celsius. And then you can cover the magnets, um, the windings with it. So um, the mirror side covers is a great idea. The question from the viewers, right? That's correct. I think it's a good idea. Um, Not only from visual point, because it will make your bike less visible because it reflects something that the surface, but also from the heat point, from the heat uh, point of view, because this mirror side covers, they reflect the sunlight and they don't get uh, hot as fast as any other side covers. But no, not everybody likes it. If I would do it, I probably made them, our original color, but most of the people want the black color. And yeah, I like black color too, but when it's very intense sun, I think the mirror side covers is a good idea. Some people using the bikes for hunting, I don't think the mirror side cover is the best idea here. Probably if you have it in a color of surrounding area will be better, but who knows, maybe I'm wrong. What else can you do to protect your motor life? No, not cut the cables and do not kill the isolation between the wire and the side cover. If you look closely between the motor cable and the side cover, there is like silicone, a heat resistant silicone. Please do not cut it or take it away, because some clients thought that this is some some um, I don't know how to say it, some trash or something they don't need, and so they pick it out, and then all the water and moisture can get inside. So please don't do it. Also, don't cut the isolation on the wire, because the motor can suck water from outside, even through the wires, through the phase wires, and from the surface between the wires. The motor can pull in and out the air together with moisture. So uh, also, it's not a good idea to drive with your bike through the very deep water. And very deep water, I mean above the axle point. So if just it barely touches the water, it's fine, because you still have sealant on the perimeter of the bike. But please don't submerge it into the water above the axle line of your motor. So it's not a good idea. I was crossing some shallow rivers and streams, of course, with my bike, but it was maybe, that deep, while the axle line was like much, much higher. So if you go in this stream or this stream and your axle line here, it's absolutely safe and okay. But yeah, don't leave your bike under the rain as well, because of course, especially when you just finish your ride, your motor is hot, and let's imagine your bike is dirty and you think, okay, good idea to clean your bike. My recommendation will be, please give it time, if you can, of course, give it time to cool down, and after this clean. Because if you start cleaning your bike immediately after a ride, your motor is hot, let's say 100-degree inside, and then you start clean it with the water, and the water will be definitely lower temperature, so you will cool down the motor. And what happens then? The air inside your motor shrink down, so your motor start work as a vacuum pump, and it want to suck in air from outside. And how can it do it? Only through the places where the wire enters the side cover. So it will suck all the moisture that you give extra while you wash the bike, and it will eventually end up inside the motor. So don't clean the bike after your ride immediately. At least give it time to cool down, and also don't point the hose or washer pressure, water pressure, uh, to the place where the cable come out of the motor. One more comment. What you think about 16-inch rim and thick 3.25 3.5 tire? Does it help to smooth out the ride on uneven terrain, off-road, or better to stick to 17-inch rim and tire because of the spoke angle? Um, a spoke angle won't be a problem even if you go with a 16, 17, 18, or 19. So it's not the problem. Um, Generally, the smaller the rim size and tire, the less heat you will get. And the bigger the wheel size, the more heat you will generate, just because you need more torque to spin bigger wheel. It's just like a pure physics. But um, if you have a smaller wheel, it might be not as comfortable over some small bumps and rocks. If you think about like small wheel and you need to go over the obstacle of this size, you know, the wheel will go up and down much faster comparing to the bigger radius or diameter wheel, which need to go above the same size obstacle, you know. That's why the off-road vehicles very often have bigger diameter wheels and rims comparing to the city cars. Like imagine like smart car with a small 15-inch wheels, and then think about, I don't know, Humvee military Hammer with a 33-inch wheels, you know. The size of the tires definitely, you know, if you go with a higher size tire and you keep smaller pressure in it, inside it, overall ride comfort will be much higher. So if you have option between, let's say, 19-inch rim with 2.5 tire thickness and let's say 17-inch 3.5 or 4-inch tire, definitely I would go with a smaller rim, bigger tire, because then you have more options to play with in terms of softness and so on, and traction as well. Arthur, what is expected life of the Vector battery I bought 4 years ago? Uh, well, the battery degrade itself, even if you don't use the bike, of course, very little, but the battery is like chemical product. It's not condensator like a physical method of storing energy. It's a chemical way of storing energy. So the reactions happen even if you don't consume or use battery or and bike. And I can explain this question, but you better watch our previous Q&A session, which I explained very detailedly all the battery tips and tricks, like I explained today about the motor, for example. So um, I think it will be useful if you just watch previous Q&A session. Okay, guys, I think it will be time to finish for today because we're already over 1 hour 7 minutes. And again, I remind you that you can watch that Q&A session in any point of time when you have free time or you want to refresh your information about some certain topic. I want to thank you for being with me this hour, for your questions, for your activity. I really glad that we can continue this Q&A already for the fourth time, and I hope the next time we will do it the same time, the same place. So please tune in next Friday, 8 p.m. Central European Time, whatever time it will be in your time zone. I will be glad to answer all of your questions that you will leave in the comments to this video after it will be published. So you have a whole week, anytime, any day you have a question, just leave them in the comments and I will answer them in our next Q&A. I think next Q&A will be with questions about shipping and packing and transporting your bike. So it will be interesting topic as well. I have a lot to tell about this. I have many interesting stories about DHL deliveries, successful and not so much. So make sure you tune in. And yes, I'm always glad to share with you the knowledge I have because I also don't, didn't get them from some secret source. I also get it from someone or from somewhere. So I'm always glad to share it with you guys. And cheers. Have a good one and see you next time. Yep. Thank you. Bye bye.